Welcome to the Databricks Skill Builder series. We're glad you're here.
Hey everyone, Arthur Jr., SSA at Databricks, specialist architect. I work in the manufacturing space, so I support a broad range of customers in that industry vertical that Databricks supports. Today, I want to make sure we're talking about something that is a broader scope than just any one manufacturing use case or solving any one specific customer problem. What I want to do is I want to walk you through starting building your own AI project on Databricks. This is important for a lot of reasons, right? I want to contextualize as we get started what different types of AI projects that we would build together, right? Or you'd want to build on Databricks. So let me take this real quick. And when I say AI shorthand today, it's probably going to mean Gen AI. That is not to say we don't have a robust and wonderful suite of tools that support other AI use cases, but shorthand today, AI, I'm going to be talking mostly about generative AI. Okay, so different sorts of AI scenarios that I see different customers and users of Databricks build include a lot of different domains, right? I see everything from customer call log use cases. I see SharePoint data exploration, right? Data exploration. I see sort of scenarios where we want to join on net new knowledge bases, right? Like, hey, we have this team knowledge base, might be like a confluence, right? We might want to even go as far to pull public sources of data. In some cases, I've seen SEC filings that people would want to pull. Even institutional knowledge that's used in specific contexts, like technical service bulletins, like if you're fixing a car, right? And it's, hey, here's the updates on what you need to fix, or context on, hey, if it's this car, it's probably broken in this specific way based on all of these technical service bulletins and updates and repair manuals, right? So these business contexts get to be massively expansive. And I want to highlight two big ways that we see folks building these AI insights on Databricks. Now, one of these is not going to be appearing in this video because we're not going to spend a lot of time on it. It's called Genie Data Rooms. Genie Data Rooms is the easiest and fastest way to get access to English queries about SQL data. So structured data that you might have, that's going to be accessible by a data room. And that's a pleasant UI over the data that you might have made in Databricks, might have made elsewhere that you want to conversationally interact with. It's really great to help different business users build insights on your data or ask questions about your data without you having to, make a net new analysis or dashboard for them. They can start to explore this. You can set some guardrails with some foundational instructions. It's a really powerful tool. However, it is not the topic of conversation today. It is a way to build these AI insights on Databricks. It is not the only way. It's a great way to get started with structured data and then build insights on that structured data. Okay. What we are going to be targeting today is the also extremely interesting Databricks agent framework. What agent framework is, it is a tool set to help you build AI systems that can scale across any data sources that you may care about attaching it to in a conversational way with any LLM, any custom system that you want to build. This allows for the maximum amount of flexibility and allows you to deploy it to serverless endpoints to consume that endpoint as part of a bigger AI system that you will build. But this is not trying to show you the web app side of building that system. It's not trying to show you exactly here's all of the governance dials and knobs that you might configure to get there. This is trying to show you how can you take data that you have in either a table, like structured data, or unstructured data, like a volume. That's what we call it at Databricks. It's kind of a mapping to a cloud storage location with governance, right? These unstructured and structured data can be elegantly combined into a cohesive system or turned into lang chain endpoints in this example, but you can use llama index, you can use semantic kernel, you can use your own PyFunk sort of custom logic if you don't like any of them, right? The end of the day, these tools are meant to accelerate the time it takes for you to build these insights, okay? What we're going to be doing from here on out is I'm going to show you the best resource to get started. The best resource to get started is what we call the Databricks Generative AI Cookbook. It's ai-cookbook.io. What the AI Cookbook tries to do, it uses that agent evaluation and agent framework, the mosaic offerings that we have here, to specifically help you build, and this term's going to be reused a lot. I'm probably going to try to highlight it a few times. High quality generative AI. I don't know if y'all have seen Gemini and the sort of, if you do a Google search, the top result that you might get as a brief summation of those results that it gets. Sometimes the summations of results can be misleading based on the data sources that they're pulling from. So in those scenarios, that Gen AI at the very beginning of a Google search can be misleading because some of the results are misleading and then give bad recommendations. And in that scenario, we consider that to be when a solution breaks trust. And the biggest thing when you are building a Gen AI system is that you should not be trying to break trust with your end users. You need to either show them small segments of high quality systems or chain these high quality systems together to build one cohesive high quality system. You should never try to just throw your documents at your data, throw documents at a Gen AI system and assume that it is going to do something to give you meaningful insights. It can be helpful, but there is a different context that those systems exist in. They are broad reach, lower quality systems, right? Because they're trying to solve a much broader problem of, let me conversationally talk to all these insights. We are here trying to solve more specific problems. Like in my company SharePoint, how do I get high quality results across different data domains or different teams? In my team's knowledge base, how do I find and discover the assets my team has made? How do I find the call log that already exists that solves this problem? How do I get trends about my call logs and different sources of all these public data to build competitive analyses about my partners and competitors? How do I understand how to fix these cars? If you are breaking trust in these domains, what happens? Your end users say, well, that was terrible. I'm never going to use that again. What do? How do we resolve this dilemma? We target small subsets of these systems as we get started, as we build out first passes, to make sure that we can prove we have made one segment high quality, one piece of this system high quality. What does that mean? Maybe I don't care about technical service bulletins for every single thing. Maybe I care about technical service bulletins for any car with this specific engine or this specific model. Maybe I care about public data sources of all the data about one company. Maybe I look at a knowledge base in a specific team domain. Maybe I look at SharePoint data for anything matching a certain topic, right? That is what you should be targeting for your first AI system solution. A smaller domain where you understand the problem space, you understand what questions people will want to ask, and that is extremely foundational. Like, understanding or representative samples of questions and users will ask, that ends up being so important to both of these systems, both Genie data rooms and the agent framework, because any AI system, you want to know what they're asking. Because how else are you going to tailor the system to be a high quality service if you don't understand that key message, right? Where we're going is I'm going to walk you through the AI cookbook, what it's trying to do, how you should start building your own RAG sample, and then how you can start to assess quality through this system. I'm not going to be running a lot of code. I might show you some code, but I'm trying to convey how you conceptually use this cookbook to help you be successful and help you get started building on Databricks. Okay? So what is the AI cookbook? It's a Git repo with some documentation around how to use the agent framework and agent evaluation in Databricks. So foundationally, agent framework, it's all of the tools that we have to help you build, deploy, test, optimize, and improve an AI project to all the way to production and consistently evaluating it at every stage. Okay. Meanwhile, the agent evaluation tooling is the specific subset of the framework that is targeting how do we assess this system is working at high quality levels and meeting our ground truth establishments. So you can say, like, hey, if we understand the questions that we want to ask, we generally want some of the answers or some idea of what the answers will look like, some dimension of the answer of like what it would mean if it's correct, to validate that this is right. So these two tools together, the agent framework and the agent evaluation, combine to allow you to, framework is the overlay deployment strategy. Evaluation helps you understand where in your system you are building, like something is working, something is not working, it's logging the right thing, it's maybe behaving incorrectly, right? That evaluation life cycle is how you know that this system is working well. As I like to tell a lot of teams that I work with, it's not that you have a linear regression problem and you have interlinear regression problem like a root mean squared error, where you know exactly what you need to build and what your metric is going to be, right? You're fitting to this line. The smaller the RMSE, the better the answer, right? That isn't necessarily true when it comes to Gen AI. You don't have an RMSE, you don't have an F1 score. You have quality assessments against either a ground truth, which is something that you manually make, right? So we can talk about like what does quality look like. So let's take what does quality look like? Well, first you need to understand what is the definition of good, right? It sounds a little foundation, it sounds a little bit basic, but so few folks I see early days have a definition of that for their AI system and their project. So what we end up doing together, and I'd love to see y'all on YouTube be able to start to build these insights yourselves or build like these definitions yourselves of what define what a correct answer may be, which is manual ground truth. Or maybe it's harder to define like one right answer. Maybe there are attributes of correct answers, right? These attributes of a correct answer are something we can engineer, right? We can assess these attributes of the correct answer, either saying like, hey, does this SQL table, does this, in a text to SQL scenario, does this SQL table have reference the fields that I'm looking for, right? Is it even in the right schema? Do I have permissions to access it? All of these different attributes of the generated SQL response that we need to make sure are correct, that compose part of that bigger right answer. So these systems, you start maybe with a simple, small ground truth of, say, 20 questions that you know the answer to. And that ground truth is an establishment of like, this is good, this is a baseline. If my model can make answers that look like this ground truth, we're in business, right? We're making something valuable in this space. But that doesn't scale, right? Maybe I'll just draw that like, nope. This, right? We're trying to scale manually labeled ground truths, doesn't scale, right? Whereas you can extract different features, different attributes of a model's response, right, over the span of time, even in real time online, right, to say, yes, this is actually an improvement on the system, one revision versus another, right? This technology, what you might see referenced as LLM as judge, but it's broader than that. It's right defining your accuracy space and comparing your generated results to the attributes that would make for a correct answer. I'm going to pause there. Any questions from the audience before we start going and going over agent framework now? Awesome. Where agent framework takes us is recognizing that we need to build out these components and pieces and evaluate them over a span of time and across all those different dimensions. So it also does these assessments of automatic LLM judgments like accuracy, safety, governance to validate that, hey, it's within these boundaries of, yes, it's relevant to the context that was provided. Yes, it's relevant to the question. Yes, it's responding in a professional way. These sorts of attributes that are more baseline attributes about your model's responses, but they are relevant and important nonetheless. So we see when you're building these systems that we need to start setting up that retrieval, right? We need that context. You see this, there's a few different code-based quick starts, okay? So I encourage you to look at different ones based on how much you've done with RAG and building AI so far, Gen AI so far. These code-based quick starts are the fastest way to try out any of the AI tech on Databricks and start to plug in your data. So if you have a short frame of time and you need to assess, hey, this RAG app is something that I want to explore and build, right? Or I want to show it to my business partner as something that I could build someday. This RAG demo, this 10-minute demo, is quickly showing a connection to, hey, this is my early day, load in all these different data, right? Let me configure some of my application, right? All these different docs that I have. And Databricks is just going to pull some docs for you to like have as a backend for the system, right? And it's going to create the storage space, which is the vector search, that retrieval component of the retrieval augmented generation of this RAG system, right? And then we will go and deploy this endpoint. So we've got all these document chunks, sections of Databricks documentation that are part of this knowledge database, right? They get saved into this vector search. And then you can ask questions that end up grounded from this vector search index, which is that retrieval component, to answer the questions that you might want to ask. So the easiest kind of quick start that we have exists right here if you're just trying to see what these components would look like live or demo them to your business partners. I would encourage exploring this. So there's some like auto run tech. You might have to change some Unity catalogs and schemas to like specific locations where you would deploy this, but it is relatively turnkey. Some parameters that you should check out, but this is meant to be that entry level. You can see, hey, this is the application that it's generating. This is the output that it has with summarized real responses. It's logging this to our model registry service called MLflow. And then this MLflow capability deploys this to a endpoint, like a serverless endpoint called model serving endpoint. And it has a review app for you to assess, like, hey, how is this model performing? Okay. So this intro, right, is a quick way for like attaching you like baseline data and exploring this service. Now, what you could do is you could attach your own data to it. If you, again, short on time, want to throw something together super quick, what I would recommend doing, and you can see like evaluations further down, you can see if we go back up, right, we'll find the place where it loads in the table. If you label the segments the same, hold on, let me find it real quick. Yep, so see there's the UC schema catalog. We actually create some tables here. Let me see if I can find the table. Right, so the table is going to be captured. Yeah, Databricks docs chunked, Databricks docs chunked index. Those tables are copied over. If you have a table full of documents that are like, say the document contents are in one column of the table, you could just swap that out and you could see how well it does, right? Maybe you haven't chunked everything perfectly. That's for a later step. Maybe there you hit some token limits in some cases. This is like the most basic baseline. You can throw some data, add a Databricks service, and be able to have conversational engagement with those documents. Be like, Arthur, I thought you said this is unstructured. You're showing me structured data. Well, the idea is that you would pull these data in, these different PDFs, docs, etc., in and save them into tables. So if you don't have stuff in a table format or even like represented as small scale as like a CSV with some table attribute fields or like some table contents fields, right? What do? Well, that's where the next solution comes in. So before I progress, any questions about this first baseline system and how it uses some pre-canned data that's already a table to consume and play around with an endpoint so you can actually explore what can this Databricks service do with some sample data? Okay. From there, this is where we're going to spend the majority of the rest of our time in this session today. So there is this service called the build and deploy POC. So this is like deploy a different POC here. I don't know why it always links to the wrong landing page. But what we want to do is we want to pull this Git code. What this Git code is the RAG app sample code. You're going to go to Databricks. You're going to either like upload this zip if you download it as a zip from GitHub. So you can see GenAI Cookbook, and you can go say code download if you wanted to, right? Or you can clone the repo. So I encourage cloning the repo through a Git folder if you can. If not, the zip method works just fine. What we can do, this Git code is the companion to the AI Cookbook. So this companion technology, what it's trying to do, it's trying to help you set up a very first pass system with all of your different unstructured documents, okay? So what you are going to do as that end user is you're going to go to this repository that I've just cloned, right? We're going to go to a RAG app sample code, and you'll see a POC app, and that's going to be where we're working out of most of the time. But we're going to go to global config first, okay? Global config, what global config is doing, it is specifically, you set up some configs, right? You need a UC catalog and a UC schema. So these are like permissions that you have to different tables and workspaces and catalogs, schemas and workspaces to this setup, right? So this UC catalog, UC schema are going to point to specific locations that you have access to where you can write to this schema. Okay, so you need to set that up first. What does that look like? Let me pause screen sharing for a second, and I'll show you how to set up a schema like that. So if I go to duplicate this tab, I'm going to go to catalog. Oh, it's a little slow today. There we go. A new catalog. Yep. Okay. There we go. Now I can view this catalog. Awesome. So we've got the second Arthur Dooner catalog. I already had one that I'm using. This is just for testing. So we're going to create a schema, and the schema is going to be rag app chatbot. Okay. So that's the catalog and schema that you're seeing here. Arthur Dooner 2, you see rag app chatbot on the side. What we want to do is we want to go to OO global config, and we want to say, you see where it says username, that's just kind of a default that they fill in. In this case, I'm going to call it Arthur Dooner 2 catalog, if I name that right. Or it's just not under, that's the catalog. And the schema is going to be, I think I named it something like this, rag app chatbot. So we're going to say rag app chatbot. So now it's going to save everything to this UC catalog, this UC schema, as it makes models, vector search endpoints, those sorts of things. So the source path itself, see the volumes, UC catalog, UC schema, source docs, that's assuming that it has a volume ready to go of your source documents, okay? So these source documents in these volumes that you'll have, right? Maybe you'd go to your schema, and you go to rag app chatbot, we make a volume, and we hit create volume. I think they called it, I want to make sure I get it right, source docs. Source docs, right? Now we have this volume. And this volume is the foundational place that we're going to store a bunch of documents. So I'm going to upload some files to this document repository. So if I go to show I don't want to show catalogs, I'm just going to download some files. I don't know if you'll be able to see my screen share as I'm doing this, but just assume that I'm getting some useful files. I've got OneDrive documents. Where's my manuals? Got like a bunch of scanned in manuals. That's just not out of order. Manuals. Okay, so we're going to upload these manuals, right? This is just like a demo. These are all PDFs, right? Obviously, you can upload anything like a PDF, PPTX, a doc, any sort of file format that you have. This example out of the box can handle PDFs, can handle docx's, can handle PPTXs, and I believe one more. We'll go back and check on that. Oh, no, I don't want to cancel that. Oh, did I cancel it? Oh, okay, so it's just a weird UI. I believe they're all there. We'll refresh. So now we've got a path where all these source documents exist. That was the most important thing for us to get in place in the first time with like our own custom docs here, right? So we go to APOC app, and now you'll see you have a lot of options, right? Option one is Databricks docs. That's just like they set up for the demo, where instead of having a bunch of docs that it saves into a volume, the first step would just pull in a table where all of those docs were already processed so you could see that demo working. What we are here to do is to build something new, right? We're here to build something custom. So I'm going to first show you what that PDF pipeline looks like, because that's not new, that's standard. Then I'll show you a more interesting, what do we do with a net new pipeline, right? Something novel. So in this case, what we're going to do is we're going to say, PDF UC volume, right? We're going to say, okay, I've got all of these different PDF configs. So you can see like the configs, this is nothing crazy. It's just going to log like, hey, the config for your data pipelines. It's saying like, hey, this is the embedding service to convert all of your documents into vectors. So all these text into vectorized sort of representations. It's using a tokenizer for that, the GTE tokenizer here. and then the output tables that it uses as the name for these tables. So like, where will all these tables get saved? It's going to get named in this format, as you can see. So there's some config here, none of which we should have to change. Okay, this is all pretty boilerplate, pretty standard. The only place that I would say, like, if you're seeing bugginess and where it's printing out some answers, see these vector search schemas? When you have your data in a format that you would then consume, right? You might have named your columns, which are unique primary keys and unique text of the chunk of the data that you have from this document. Those might be different than the labels that they have here, okay? So you might have to change chunk ID to be the unique ID of your table. You might have to change the chunk text from the chunked text sort of label to whatever that text segment is labeled as a column in your new table that's created for you. And you might have to change the document URI. The document URI is like a universal reference to say, like, this is where the original document is from. Generally, when I'm getting started, that's less important to me. So I'll comment it out to make sure nothing breaks, and then I'll layer it back in when I want to improve my retrieval system, because generally I don't always have that path cleaned up and in this format necessarily. So another big parameter I want to draw your attention to, you can see how it says query type ANN. So ANN is semantic search. If you want a combination of hybrid of keyword and semantic search, right? That's where you can type hybrid instead, right? And that will use both different retrieval mechanisms. So it changes how the retrieval in vector space, or it broadens to be beyond just vector space. If you want to return more than 5 documents or less, you change this little variable here. It's pretty well documented. I just want you to be aware of all these settings. I think, if I'm not mistaken, I forget if it's an OO config or the higher level config. Let me see if it's DBRX. Yeah. So see the LLM endpoint name? If you do not want to use DBRX, let's say you wanted to use Llama, what I want you to see, just this is really quick and easy, is we can go to serving, we can go to MetaLlama 31405 or 3170. I'm going to do 70 because there's less folks using it right now. So we're going to say 3170B. This is the string that you would copy. You click into it, you say view details, you copy all this, right? And then we paste it in. Now your system's, instead of using DBRX, it's using Meta, like Llama 370B. So fully managed endpoint, you don't need to think about any of the GPUs here. It's calling out to these different models. You might ask, I want to use OpenAI instead. A lot of folks I see I work with are using OpenAI. That might be their chosen model configuration. And we never say, like, you can't use OpenAI or Anthropic or whatever on our platform. That's where we recommend you set up what's called external models. Databricks. So if you just take a look at this, this is truly like using your permissions and configuration to all these different services, right? That you might already have an endpoint on to consume. So you can say, I can target any of these different types of interactions with OpenAI, Azure OpenAI, Anthropic. And you can see the endpoint configuration down here. So you create this endpoint with your secret key. It is truly this easy. So you just give it a name. You say it's an external model. This is the model. This is the provider. This is the task I needed to do, which the tables above, like the different types of interaction modalities you have. And then you give it that API key from Anthropic, OpenAI, wherever, which generally you keep in a secret store is best practice, right? To consume as a endpoint that you can then pick up in this additional, in this RAG service. So you just change the endpoint name here to whatever name you set it to. Any questions about the config, folks? I know this is like, I bounced around a little bit, but this is the big changes that you would make on this system to have it fit some of your documents right out of the box. So, and assuming we're using PDFs, this is the path. Okay, so O1 is actually super easy. It's not doing anything technical for you. It's other than telling you if something's broken, like an infra component or like maybe you pointed to the wrong volume. O1 is a validation step. So it effectively checks like, hey, does this catalog exist? Does the schema exist? Do I have the vector search endpoint? Do I have the chain code file? And that's like the actual like Gen AI logic that you're going to see, right? This then make sure is the embedding endpoint online, which is the thing that converts everything into vectors, all the data that you have, and then is the LLM online, and can we spin up a model serving endpoint? So if all of those are vector search endpoint, if all those work, then we validated that we are in a good spot to be able to run the rest, and it shouldn't break. Okay. Now, the POC data pipeline. This is imagine you have your data steps and you want to extract any specific fields. This just loads all the PDFs. It parses them out and it chunks them, right? So it converts those chunks into embeddings under the hood and it stores them in that vector search index. So it gets it all ready so you can do those fuzzy matching queries against a hybrid or semantic search, right? So we can say, we're installing all these packages, nothing that you should really worry about. Right, here's all like the configs, it's just logging to MLflow, like, hey, we're running this data pipeline, it's like data pipeline steps. We've got these files that we're loading in from that folder. So pipeline config, get file format, and then source path. That source path is that source path variable that we set earlier, which is like the volume location. It's going to write those raw files to a new table. So let's see if it does that. I'm not going to stay attached to a compute the whole time, but we can play around with this for a second. We're early days. I'm probably not going to show you much more code like running this, but we can run it. In the meanwhile, so then we use a parsing function. You might have another parsing function. You might have a best-in-class like external service. You might have another custom Python thing. You might have another language thing. We call out to that service, right, to parse the PDF. So this is just a user-defined function in Databricks to parse all of these PDFs. So again, nothing you can really think about too much. This is where you would change the parsing if you wanted to capture specific fields, specific insights, or use a different service, right? So this is the logic. This is the instantiation of like this is a UDF. This is the format that it's returning an output in, and this is how we will call it. And it runs that parsing step. We'll let you know if any of them failed to parse, right? And we'll write those to that parsed table. Then we chunk all of those tables into smaller segments, or chunk all those docs into smaller segments that are part of a table with, I believe, the explode function. No, I think we use a custom function. We use the custom function, then we use explode. So this is like segmenting those documents into specific chunks of that doc. So if it's ready to chunk, this is the actual logic that segments it over, and then we then say chunk actually wrap it as a user-defined function, call that chunking function. So nothing crazy there. Again, it's just like the same thing twice, just one's parsing, one's chunking. Then we say using a vector search endpoint, which is just a logical grouping of vector searches, we want to deploy to what's called a vector search index. So this vector search client, which is just like the abstraction that we're working with, is checking to see if the endpoint exists, right? And tell me the index is on this endpoint. If the index already exists, don't recreate it unless you say force delete. If it does not exist, it will create it. So the actual magic here is here. So this is where you have to change things if your primary key or embedding columns are different. So your primary key, if you change the name of the files and the tables and how all this works, you need to make sure the primary key is different, whatever the unique identifier of each row is. And then the embedding source column, which is the actual text that we vectorized, that needs to be changed. Everything else should largely stay the same. This will take 10-15 minutes. You're not doing anything wrong. It's provisioning some compute the first time. The more data that you have, the more cost associated with this database that is online all the time. So please If you throw like one of the reasons I say don't throw infinite data at this problem right away, there is an associated cost to this. This is not the conversation to talk about cost. It should be relatively minimal at tens of gigabytes, that sort of range, where I imagine we'd be testing in these spaces. As you scale up, cost becomes more of a consideration because you got this huge vector search document space for retrieval that you can just pull up and invoke anytime. That's non-trivial to keep that compute up, so make sure to spin down your index if you aren't using it and it's got a lot of data. So when all this is running, we can test the index and all the index components work. Right? Amazing. Talk to me, message me, reply to the comments if this is broken. Then we actually go and we say, let's deploy POC to review out. This is the actual bundling of all the ML logic. Now this step, super easy. There isn't a lot going on here. All it's doing, it's taking a chain code file, it's bundling it into an object, it's testing it. So you can say it's actually logging that lang chain model. And then it's testing it. And when it is bundled and saved, it then promotes it to Unity catalog. So these are just instructions for like someone to play around with and test this endpoint if you share it with them. So you can change the string, nothing bad happens. And you need to deploy. So this actually deploys it. Agents.deploy deploys it to a model serving endpoint after we've registered that model. This is just going to tell you like, hey, this is how we're doing. It will take another 15-20 minutes, right? But again, don't wait on this endpoint to test things. Please test it locally in this MLflow LangChain invoke, right? This invoke step after that load model allows you to just test this logic that you've made without waiting for these long deployment life cycles. I encourage you to use these chains to like throw all your questions against and assess, and you'll see some of that evaluation later. So this will make a pretty review app for you to consume, and you grant different users who might be interested in consuming it to this service, right? I'll show you the service at the end. I just want to get through the rest of the code. The multi-turn RAG chain, we're just skipping around a little bit, this is where all of the LLM logic is. It's got some like, hey, variables for vector search, variables for like the retriever schema. Again, if you changed some of these variables or if you removed doc-URI, you need to comment that out, otherwise it will break. Be like, hey, where's doc-URI? So be thoughtful about that. If it's throwing an error, it's probably something to do with one of these sections. It's like, hey, I don't have these schema fields. And so that would be something to validate and check that you have in that format. And then if we go a little bit lower, so this is like the base template. This is doing a little bit of like rewriting historic chat history to validate that the chat is like, take all of the historical conversation that you've had in this context with the LLM, summarize it, and then give it as context for like the next step of that LLM. So this is like the query rewrite template that it's giving. And it's saying, hey, here's the chat history, here's the question. This is the model that we're loading in. So we changed the parameter, so it'll be llama. It was by default DBRX. And this is your LLM logic. If you're like, hey, I want a bunch of different retrievers, right? If you're saying, hey, I want conditionals like runnable parallels or other LangChain components here, this is the code that you need to change. This is the point where if you're trying to make it evaluate, consume, do additional steps, classify, this is the component where you're going to be modifying it. And this requires a knowledge of LangChain's LangChain expression language, LCEL. And that's all those like tildes. Each one of these takes an input, or you take some like definitional inputs, and then always outputs a certain format. So as you can see, this takes in all these inputs: question, chat history, format, chat history, runnable pass-through, which is just like a pass-through of like pass all those historical parameters through, then say, hey, this is a branch where we take all, if there's any chat history, going to rewrite, it's going to use a model, it's going to output that as a string. So it's taking all of that as context, right? It's retrieving anything new, as with the vector search, with like the question that's relevant. it's getting a formatter against that outputted vector search, and then it is getting that formatted chat history, running with the question, saving that as a prompt, or I should say, sending that to the prompt that you have given it. You can see prompt is your system prompt. Right, so there's the LLM system prompt, which is a variable in the config, and then the user question, which follows right beneath, right? So that prompt, all of that's passed through with all of the context from previous, from the vector search and previous context from the user. And then it passes all that to the model evaluates, it formats, we format an output, and that's done. That's all this is doing. It's a really simple example. And that's why I say if you need to change how the LLM logic is evaluated, as add a classifier, put it in an agent loop, any of those steps, this is where you would change this chain. So you understand the deployment, you understand the actual language model chain, like the logic that you have over it. What I want you to understand is that when you have this endpoint up, it will give you the opportunity to have responses from those requests, right? So which will be evaluated, like this is good, this is bad, or this has additional feedback. So this is making an evaluation set out of the good answers, right? And then it will include the expected response if it's a bad answer. So it's trying to get all of these assessments together, right? And then assess, hey, this table, because it's capturing all of the logs out of when someone puts a query into this endpoint, right? It runs this. You get the tables back, and it allows an inspection of hey, this is the evaluation set that we're running. So we're seeing hey, how did this assessment work? And then finally, we can review the POC quality, which is from that evaluation set that was from these inference tables. So now that we've saved all those tables, here are the different attributes that we care about: the request, expected response, expected retrieve context. We can evaluate this application with the MLflow.evaluate capability. Now, the MLflow evaluate has a lot of built-in assessments, as I was alluding to, but it makes sense to layer in additional custom assessments with LLM as judge. And then you'll see, we look at the evaluation results, that'll be like a visual. That is this system, right? You can layer and repeat this for more different types of documents, right? This is not very hard, something we can go through in a couple hours. But I wanted to share where you could get caught up and waste a ton of hours, like why is this not working? What config might be wrong? And I want to show you that at the end of the day, when you have this all set up, right, and you have a system full of SEC filings, for example, that you might want to query questions about, maybe against one company. I only put one company's worth of data in this one. You can see this is tell me about any potential litigiousness, right? It has these complete summaries of how these the context that's available against any significantly litigious sections, right? To give insights about these end user scenarios. So again, think about the questions that your business is going to ask, right? That's very important. Establish a small 20 question ground truth. Throw your documents against the agent framework. Again, small sample, small scope. And at the end of the day, you have this system that allows you to test, see if it's working well. You might layer in additional features of your definition of what working well looks like. And we can do a follow-up video that covers that evaluation journey, that repetition over time. But this is how you get started building your own Gen AI apps on Databricks. Any questions from the audience before we call it for today and maybe do a follow-up on evaluation? Awesome. Well, I appreciate everyone's time. I hope I hope you all have a wonderful day and you had a wonderful working session together. Let me know how far you make it along these projects, right? we're here to help on Databricks side. If you're doing this on Databricks, there's going to be solution architects, specialist solution architects who are interested in helping you build these use cases. So please do not be a stranger. We are here to help. Gen AI, building Gen AI can sometimes be easy. Let me throw documents at something and see if it works. Building high quality Gen AI is not always easy. There's compound components to this. There's ways we have to engineer to make high quality, and we want to be up to the task to support you. I hope you have a wonderful day. Live long and prosper.